Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 11th, 2026, just 3 days ago. It introduces Solar Open, a 102 billion parameter mixture of experts model designed to solve the data scarcity problem for underserved languages by synthesizing 4.5 trillion tokens of high-quality training data. The paper is titled Solar Open Technical Report, and as we'll see later, the methodology allows it to match top-tier global models while using significantly less training data. So Figure 1 presents the overall performance of Solar Open compared to comparable models like GPT-OS 120B. The results are split into two sections, with Korean benchmarks on the left and English on the right. In the Korean section, Solar Open, shown in purple, excels in specialized domains. Specifically, in the medical category, it scores 84.4, which clearly outperforms the others. Then, moving to the English section on the right, the model remains highly competitive in general knowledge and math, proving that optimizing for an underserved language does not sacrifice global capabilities. Well, to support the specialized performance we just saw, the team designed a custom tokenizer, and Table 1 details the specific data mix used to train it. While English remains the largest component at 40% to maintain general capabilities, notice that Korean is significantly oversampled to 22%. This adjustment ensures the model represents Korean characters efficiently rather than fragmenting them. Furthermore, because reasoning is a core goal, code and math data together make up another substantial 22% of the vocabulary foundation. Alright. Figure 2 shows exactly how that custom vocabulary translates into real-world efficiency. The chart measures compression rate in bytes per token, where taller bars indicate the model packs more text into each unit. In the first group for Korean, notice the massive jump. While global models struggle, Solar Open, the purple bar, reaches nearly 7 bytes per token, far exceeding the baselines. Importantly, in the English and code sections, it stays level with top contenders, proving that specialized efficiency doesn't come at the cost of general performance. So Table 2 details the specific architecture that supports this performance. The top section lists the model size at over 102 billion parameters, but thanks to the sparse design, only 12 billion are active for any single token. This significantly lowers the compute required for inference. Also, note the vocabulary size of roughly 196,000. This expanded vocabulary is what drives the high compression rates we just analyzed. Finally, the bottom section outlines the expert strategy, utilizing 128 routed experts, plus a single shared expert to capture common patterns. Okay, Figure 4 maps out the training curriculum, which follows a noisy to high-quality progression. On the far left, Phase 1 starts with a massive 10.8 trillion tokens, using mostly real data to build a broad foundation. As we move right through the later phases, the total volume drops because the team applies stricter quality filters. At the same time, look at the hatched sections. The synthetic data ratio climbs steadily, peaking at over 64% in Phase 2C to focus on reasoning. So, Table 5 now details the resulting performance on Korean benchmarks. The model is compared here against strong baselines like GPT-OS 120B and GLM 4.5 Air. In the general category at the top, Solar Open leads on key tests like KMMLU. However, the standout results appear in the specialized domains below. For instance, look at the medical row. The model scores 84.4, significantly outperforming the competition. Finally, the preference section at the bottom confirms this quality, with a leading score of 79.9 on Co-Arena Hard. Wrapping up, the key takeaway is that data scarcity doesn't have to limit AI for underserved languages. Solar Open proves that combining high-quality synthetic data with a smart curriculum allows specialized models to compete globally. This methodology offers a real blueprint for democratizing high-performance AI beyond just English. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.